Hey, I want to talk about one of the common pitfalls in MMM, and we already saw this in the previous video, and it is known as the Adstock, also known as the attribution window. So this is kind of simple to conceptualize. All this means is if I see an ad today, will I make a purchase today or from a week from now? For example, if I saw a TV ad, will I purchase today by going to the store, or will I purchase in 1 week, 2 week, or 3 weeks from now? And that is what we want to model and consider in our media mix modeling. So whenever you've seen a MMM report, you will see a graph that looks something like this, where we have weeks on the x-axis, and on the y-axis, we usually have the effect up to 100%. And you'll see a graph that goes like this, or even like this. So we want to understand what this exactly means. We know that this means ad stock, and it's trying to understand and model the delay from seeing an ad to making that purchase. But is there more to this ad stock? And turns out there is a bit more to this ad stock, but not that much. So let me simplify this. So if you think about it, it can be put into two buckets. So the first one, I would like to call it as fixed decay. And the second one is obviously the opposite of it, flexible decay. And within these, we can have different models. There's one called the geometric. And let's look at this one by one before looking at all of them together. Now, I've just put this interesting looking equation over here, but don't worry, it's not that difficult, and we don't even have to remember this. All we have to remember here is there is a term called beta term, which is greater than 0, and it usually goes up to 1. And to make it more visual, we can just plot this, and this is what we usually see. So this is a higher beta over here. Let's say this was beta 0.6, and then we have one more over here. Maybe this is beta 0.3, and then maybe this is beta 0.1, and so on. So this is a fixed decay. So that is what we put in this category over here. This is geometric, fixed decay, and you'll see this a lot more in your ad stocks. Then there is another one over here in the fixed decay category called as delayed geometric. And here I've just put this complex looking formula over here. Again, don't worry too much about this formula. So this is still very similar to what we saw over here with the geometric ad stock, but this actually differs very slightly. So here we have this special term over here called the theta, which is just adding a delay before maximum effect is reached. So again, on a y-axis, we had effect, right? So this is the effect of the ad. This is 100%, and this is 0%, and this is the number of weeks. And this theta term adds a delay before hitting the maximum effect. So this could look something like this. So this is when we hit the maximum effect. And then we have the Lmax, which just define how many weeks we go on. And then after that, the effect becomes 0. So we go to 0 over here. So maybe this is 3 weeks. So that is the 0 term. And similarly, you can have different beta values here as well, so that you keep moving like this. So maybe this is another channel which takes a while to hit the maximum effect, like a TV ad, a promotional ad, or a Super Bowl ad, etc. And then it takes a while for it to decay, and then it eventually becomes 0. So that's all this is, delayed geometric. Now here's the good news. Even though we have two more models to look at, 80% of media mix modeling can be just done within these two ad stock models that we've looked at so far. But there are scenarios where you might need a very custom sort of an ad stock curve, and some of the packages do support this. But two of the more popular ones, ad stock, are Weibull CDF and PDF that you will see around in some of the open source packages. So if I just move back to our split over here that we started off with, fixed decay and then flexible decay. And in the flexible decay, we also have Weibull CDF and Weibull PDF. Now, if you're familiar with some of the Weibull analysis, it's very popular in reliability studies like time to failure and those kind of studies, but we can also use this in marketing as well. So just a short aside on what is PDF and CDF, because we have Weibull in the name over here. So some stats over here. So if you look at a normal distribution like this, so this is probability distribution function. So imagine you had a normal distribution, probability distribution function like this, and maybe we're doing a study on average age of people that look at our ads, and we say we are interested in this area over here. So how do we find that out? What is the area that we get from this section of our distribution? Let's say this is between 60 and 70 age demographic. And if you want to find out this area, a really easy way to do that would be by looking at the CDF, cumulative density function, which goes something like this. And you can literally map this over here. So this goes to 0 to 1, and you have this line over here and this line over here. So maybe this is 0.9 and this is 0.95, and then this would be 0.05 area. So this is where you would use CDF. And there's also PPF, where imagine you know the area, but you want to find out the numbers down here. So you would get a PPF curve, where imagine you knew the area of this. Let's say this is 0.5. So you can plot this on this axis over here. And let's say 0.65 was here. And you would just take the y-axis and you would get the value 60 over here. So that's a simple divergence that we just took on PDF, CDFs, and PPFs, but we don't have to worry too much about those. We are interested in viable PDF and CDF. Let me just draw this one without the complicated equations and such. So like I said, with viable CDF, we have a flexible decay now instead of what we were seeing so far with just a simple fixed decay. So we have two terms in this equation. We have the K and the lambda. Let me draw that one again, lambda. So this is for the shape and this is for the scale. Let me just draw this up so that it's easy for you to visualize. So this could look something like this, where you go straight and then you have a shape like this, like an S kind of shape. And if your media channel kind of resembles this, then this is a perfect example where you would use a viable CDF. And you could even get the kind of geometric decay that you were working on as well with the shape. If you reduce the shape K like this, so you might even get like this in your viable CDF Adstock. So this would be Adstock. And then we have the last one, which is viable PDF, which is similar to what we just saw with the CDF over here. We still have the K shape term and the scale term over here, but the only difference is we can add a delay before we reach maximum effect. So similar to the delayed geometry that we looked at. So you can go something like this and have another S shape kind of a shape. So the only difference between this and delayed geometric was that this can have kind of an S shape here and here as well. Now I know that was a bit lengthy one, but hopefully you get the idea. But think about this, we can get away with most of our analysis with just a simple fixed decay, which is the geometric and the delayed geometric, and 80% of your MMM will work fine. But in those rare cases where you have some weird media mixes and where you really have time and energy to go in deeper into this, then viable is a perfect solution for you.